When you see the airplane arriving here on time, the entire team ready, you can imagine that maybe it's easy to fly across America with a solar-powered airplane. But I tell you, if it seems easy like this, it's because there was 10 years to conceive, design, construct, test and operate this airplane, about 9 months of the entire team to plan this across America mission, to get all the permissions, all the operations, negotiations with the airport, civil aviation, logistic, weather. You know, we have statistics of weather of several years. And then when everything was ready, well, we could take off with André, one after the other, making 5 legs from San Francisco to here, and then André will continue to New York. And it might seem easy, but it's the result of a lot of work, I tell you.
It was great learning as well. We thought we were ready for the flight around the world, but we discovered that we still had a lot of things to learn, and we did. You know that we lost the hangar before being able to land in St. Louis, so we have to find new ways, in fact, to protect this airplane. We had to split the last leg in two, and we had a lot of difficulty this morning. I don't know if you followed our website, but at a certain stage, we almost thought we had to ground the airplane and not having the possibility to bring it here in Washington, D.C. So it was really tense, and the emotional level was very, very high.
Yeah, the airplane was full of water because of the fog, and it was condensing, and there was water pouring into the ailerons, into the gondolas for the engine. So we took 3 hours to clean it, to dry it, and at the end it worked. I tell you, I think it was the most stressful moment in our mission across America this morning. We'll remember it forever. but we're here. And maybe what is really important to explain is not only what we're doing, because of course everybody knows that crossing America coast to coast is a mythical goal in the aviation's history since 100 years, but why we do it. And it's so important to be able to demonstrate what these clean technologies can achieve. You know, very often when we speak of clean technologies, people say, hey, what is it? It's boring, it's too expensive, it doesn't work, it's for a niche. Well, at the end, with these clean technologies, you can have a solar airplane that is so efficient, so reliable that it can fly without any fuel day and night. And this is just the result of the best electrical motors, the best batteries, the best insulation material, the best light carbon fiber structure, the best lighting systems, as you've seen here during the landing. All this makes the airplane so energy efficient that it can fly with no fuel, just with the sun during the day, to fly almost forever. And this is what we want to demonstrate. We can achieve unbelievable things with energy efficiency and clean technologies. This is why we had this clean generation flag brought to every stopover. It was given to the governor of every state until now, and it will be given Monday to the Secretary of Energy. And then we'll continue to New York for the last leg. It will be the climax. It will be André flying the plane for the last leg. So we can have the picture over the Golden Gate, made 2 months ago, and the Statue of Liberty hopefully in 2 weeks. And we'll bring back to Europe a lot of memories of your extraordinary country of pioneers where aviation was born. This country who has inspired us, motivated us to do what we're doing now.
How was the flight into DC?
Well, the flight, you know, it was fabulous because we had this goal of arriving to Washington and then to New York. And I tell you, when I saw the lights of the city of Washington, D.C., I started to have my heart beating much stronger, and that's the moment where the emotion came.
Your aircraft will be on display tomorrow at the most famous aviation museum in this country, the Smithsonian Air and Space Museum. What are your thoughts as that plane joins the other major aircraft in that museum?
Well, the Smithsonian Air and Space Museum is not only the most famous museum in the country, it's the most famous aviation museum in the world. And it's true that our collaboration with the Smithsonian is something that pleases us very much. We'll have this airplane for a week in the Smithsonian. Well, I'm personally very much touched by that because I have the capsule of the balloon I used to fly around the world non-stop in 1999, which is already on display in the Smithsonian Marine Space Museum, together with the capsule of Apollo 11 and the Spirit of St. Louis. So for a short while, there will be Solar Impulse and the Brightening Orbiter 3 capsule together. So of course I'm really pleased, and maybe one day the plane will stay forever in this museum. We'll see.
Bertrand, Warren Morningstar from AOPA. Talk to me about how some of the technologies that you pioneered here may find their way into the kind of aircraft that our members fly, the general aviation aircraft.
Aviation is probably the last mean of transport that can do without any fuel, because it needs to carry light fuel, and kerosene is a light fuel. So airplanes will become lighter, they will become more efficient, but Solar Impulse does not have the goal of making a revolution in air transport, to be very honest. We have the goal of making a revolution in the mindset of the people when they think about energy, when they think about clean technologies, when they think about efficiency. And all these technologies we have in the plane can be used everywhere on the ground, for cars, for trucks, for construction of houses, for lighting systems, for heating or cooling systems. And if the world would use today, globally, all the technologies that we demonstrate in Solar Impulse, we would be able to divide by 2 our energy consumption already today and produce half of our need with renewable sources. And this would create jobs. It would make profit, because the world needs these new efficient products on the market. The world badly needs that. So the industries who are going to develop them are going to be very, very successful. And at the same time, they will contribute to the protection of the environment. So it's really a win-win. And that's our goal.
Interestingly, if you look at the partners and the companies who have brought the technologies which is on this airplane, all but one are not coming from the aviation world. And their interest is to develop technologies for their own applications, their clients, which are automobile industry, home building, appliances, and so on. And what we have here is already going into this product. So these are the side benefits, in fact, of these developments and the research which has been done to make this airplane fly.
What are the differences you find between flying across Europe and flying across the United States?
For a Swiss project, flying across Europe is something logical. You know, we stay almost at home. Coming to America is something different. Coming to America is the highest level you can do with an airplane like that. You come to the country of the pioneers who invented aviation 100 years ago. And aviation has made now a complete cycle. You know, we can even go to the moon. And we're starting now a new cycle to fly, but with no fuel at all. So we start all over again with an airplane that flies slowly, that is sensitive to turbulence, that has only one person on board, exactly like 100 years ago. But it has no fuel and it flies forever. And a country like the United States has this capability of enthusiasm for innovation. And maybe this is what links Switzerland and the United States so well. It's this spirit of innovation, this knowledge that we cannot go into the future without innovation. So the Swiss people feel well in America.
You know, when we contacted airports like Washington here, Dallas International Airports, just to see what can be done, I mean, where could we land? The question was not where, the question was just how. So it was evident for the airport authorities that this airplane had to come. And this is the spirit we have found all over the countries. And that's the spirit we also have found at the FAA, because to integrate this airplane into the traffic is tremendously difficult. And the FAA from day one decided that, I guess they wanted to help us to achieve this mission, and did everything to make it possible. And I think it was very hard, but they were so helpful. It's really something to underline.
Yeah, this would have been impossible without the collaboration of the air traffic controllers and the FAA. Absolutely. We're very thankful to everything they've done to facilitate this mission.
And maybe one word which is also interesting, that's true that this airplane is like being in 1915 if you compare to traditional aviation. So we had one pilot on board of this airplane, but we had a lot of virtual passengers. And these are the people who have subscribed, in fact, to our website since we departed from San Francisco. Many thousands of people who came to see this airplane visited us, and people who have their names now in this USB key, who has been his virtual passengers.
And André is virtual passenger.
And
also.
for the next flight to New York as well.
For the around the world flight that you all are planning, I know you're building a second aircraft. What's going to be different in that plane, and why do you need to build a different aircraft for that?
This airplane you see behind, it's a first prototype airplane. That's a test bench. That's a flying laboratory. So it was designed to demonstrate we can fly day and night, which we did 2 years ago. But it's not an airplane to travel, certainly not over the oceans. That's the reason also why, in fact, we have limited the flight duration for maximum 24 hours. Interestingly, energy-wise, this airplane could have done the flight from San Francisco to New York non-stop, but the pilot could not. So we had to develop a different kind of cockpit to make, I would say, the life possible for many days, many nights. It will also be able to fly in clouds. It will also be able to fly in humid environments, which this airplane cannot. And that's the problem we had this morning when we were in Cincinnati with the fog. So these are the modifications that will bring to the second generation. And of course, better performance because technology has been improving over time.
Oui, sinon juste une. No, go ahead.
What things in your cockpit would the average pilot recognize? Your instruments, your avionics, and what would be different from performance?
We have altimeters, variometers, radio, transponder, like in a normal airplane. But we all have also an instrument that we call the power management computer, which gives everything, temperature, voltage, RPM, power, everything from the engine and the batteries and the MPPT and the solar cells. And we also have something really interesting that probably a lot of pilots will like to have on their airplane. It's a very, very precise indication of the bank. Banking left or right, with a precision of 1 degree. And this has been made by the Omega company, the watch company.
We call it the Omega instrument.
Yeah.
I mean,
exactly.
It became the official name of the product.
And this, on a normal airplane, would give an extremely precise indication of the bank. And I'm sure this will make its way through to normal aviation.
Okay, so I think
Very last one in French.
come on Monday, you will have more.